So in this topic, let's try to discuss the integration of in the form of 1 over x plus b, right? So in this kind of question, there are only two formulas that you need to remember. The first one is that the integral of 1 over x dx is equal to natural logarithm of x plus c, okay? And the integral of 1 over ax plus b with respect to x is equal to 1 over a ln of ax plus b plus c. Okay, as simple as that. So let's try to apply this one to these questions here. So for example, the first one, the integral of 6x dx. Again, by using formula number, the first one, then this can be 6. The integral of 1 over x dx is equal to 6 ln x plus c. That's it. I think my handwriting is a little bad. Not little bad. I think it's really ugly. So that's it. Okay. So the same thing also with the other one. Uh, the letter C, D, E are all the same. Okay, so I will just try to answer one of them. So again, for this one, what you can do is to put that 6 first outside if you want. So you put that 6 outside. So 6, the integral of 1 over 2x minus 5 dx. And then just apply this formula. So therefore, that's going to be 6. Your a is 2 times 1 over 2 ln x, sorry, not ln x, but ln 2x minus 5. Okay, then you have there plus c, or you have there 3 ln 2x minus 5. And that's it. Now, letter A here has that function, I mean, definite integral. So what we're going to do is try to integrate, then plug it in. So, and then let's try to visualize that geometrically. Let me just erase this because I have no space. Okay, and let me just use other, maybe other color like black. So you have there the integral, I said black, anyways, becomes red. 0 to 5, 1 over x plus 2 dx. Okay, so just for you to be able to imagine, uh, this one, the graph of this is the vertical asymptote. Okay, x plus 2 equals 0, x equals -2. Let's say that's -2. So this is going to be the vertical asymptote. So the graph of this will not touch that one. And then this is going to be the final graph. Okay, something like this. So that will be the graph. And it will never touch the x-axis. Okay, and it's from 0 to 5. So meaning if this is your 0 and that is your 5, so from 0 to 5 is that you are actually looking for this area bounded by these two lines, x equals 0 and x is equal to 5. And that region is equal to the integral of this one. So let's compute the integral. The integral of 1 over x plus 2 is ln x plus 2. And then from 0 to 5. And then again, you plug in the 5 first, so that's ln 7 minus ln 2. Okay, and that's it. That's already the final answer. Just press it into your calculator, because unfortunately I have no calculator in here, and I have, what do I have here? Like okay, let me try ln 7 minus ln2. I'm just using this calculator in my phone. So it says here 1.25, 1.25. So approximately 1.25 in three significant figure. Okay, so again, the integral, the definite integral, the definition is like area bounded by the two lines x equals 0 and x equals 5 and under the curve. Okay, so letter D, E, and F are all the same. So let's try to answer some sort of this question. I'm gonna take letter C because it looks like a little bit complicated. So if you would be able to do letter C, definitely you can do the A and the B. Okay, so let's do it. So what you can do is that just simply take the integral of these three terms. The integral of 2x, okay? The integral of 2x is what? Oh my God. Is equal to 2. The integral of 2x is equal to 2x squared over 2. Okay, minus x. I will not simplify first, so you'll be able to see plus 4 times 1/2 ln 2x plus 3, okay? And that is from -1 to 3, all right? So you have there, this is now x squared minus x plus 2 ln 2x plus 3 from -1 to 3. So basically, just simply plug in the 3 and the -1. Now, you might be asking, Mr. Daniel, what is the graph of this function here? Again, just for you to be able to understand it better, let's try to draw the graph of this part. Okay, so in this one, the one that you need to look at is what is this is just a sketch. So you need to look at what is the vertical asymptote. The vertical asymptote is that you equate the 2x plus 3 into 0. So 2x plus 3 equals 0. So x equals to -3 over 2 or -1.5. So what you're going to do is take a look of -1.5, maybe there. Okay, and then you draw a vertical line, broken line, okay, because it is the vertical asymptote. So after taking the vertical asymptote, there's going to be another asymptote. And what is that one? There is what we call as an oblique asymptote. And the oblique asymptote here is this function, this part. Just make it equal to the y, and then that will be your oblique asymptote. Let me just write the word oblique, meaning slanting. Okay, remember there are three kinds of asymptote. One is vertical asymptote, one is horizontal asymptote, and one is oblique asymptote. Okay, so in this one, we need to draw the graph of that oblique asymptote. And for us to be able to draw the graph, let us take the what I call the ordinates. Okay, the y and the x intercept. So if x is equal to 0, it appears to be that the y is equal to -1. And if your y is equal to 0, it appears that your x is equal to 1 over 2. So you need to plug it in now. 0, negative, 0, -1. So 0, -1. I will just use red, green, sorry. So 0 there and -1. Maybe this. And then you have there 1/2 and 0. So 1/2 is here, for example, and 0. All right. And then what you're going to do is just simply draw lines that connect them. Okay. Now, these are oblique asymptotes. Again, asymptotes. And the graph, the curve will not pass through these two asymptotes. Okay? Now, so what you're gonna do now is you identify, because there are possibilities. Either these are the possibilities, okay? I will just use pink. I'm gonna use pink. The first possibility is that either it's here, okay? Or the other possibility, I'm gonna use another color, is either this one and this one. So there are two possibilities, either the pink one or the brown one. But the question is, which is which? So what you're going to do is you have the test value. So the test value is that if x is 0, you test with the y. You test with this one. Okay, you test with it. If x is 0, this is equal to 0 minus 1. If x is 0, that is equal to 4 over 3. So negative 1 plus 4 over 3 is equal to 1 over 3. So definitely that 1 over 3 is positive. So basically, it's actually somewhere here on top here. Okay? So now we know that it's not perfect. So now we know that is actually the pink area. So that is now the graph. Okay, you just need to test that 0, 0, and then you identify whether it is on this in between those two green or on the side of those two vertical and horizontal asymptotes. Okay, now again, I'm just explaining this one just for you to visualize what is that question all about. Some of you can actually answer or find the integral, but then it's going to be difficult to visualize. Okay, so and then what we're going to do now is that from negative 1 to 3. Okay, from negative 1 to 3. So basically, what you're going to have there is that in here until 3. Look at that. Okay, so the area, you are now looking for the area under the curve. Okay, so basically, my dear, you have there these two, actually this region and this region. Okay, so basically that's what you are looking for. Okay, so from here, my dear, from here, what you're gonna say, what you're gonna see is that you cannot just simply take the integral or plug in directly from negative 1 to 3. The safest one is to plug in from negative 1 to 0, okay, and then from 0 to 3. Okay, why from negative 1 to 0? Because as you can see in here, it is well, it's not that perfect, but then it appears to be that it is. Remember, the definition is, let's say the curve is like this, okay, and if it is here, and the other one is here, what you're gonna do is you remember it's between the curve and the x-axis. Okay, between the curve and the x-axis. So therefore, you need to get this region, and then you need to get this region. Okay, so that's what happens here. All right. So what we're gonna do is just simply plug in first negative 1 to 0, and then 0 to 3. So let's try to do that one. So let me just erase this. Again, I just apologize if you think it's too difficult. Actually, I just want you to visualize the graph, because If you are already in further math, for example, then by just looking into the question like this, you should know, you can imagine what is the graph of this one, okay? You can imagine what is the graph of that. You can imagine what is the graph of that, okay? By just merely looking. So these are the stuff that you actually need to practice on, okay? But again, the purpose is just the integral. All right, so again, just for us to make sure, let's just plug in from -1 to 0 and then from 0 to 3. Because that's what the graph looks like. So let's break it down. From -1 to 0 first, and then later on, let's do from 0 to 3, okay? So let me just erase this. So I have extra space. So you just need to be careful, okay? So plug in the 0. So 0 minus 0 plus 2 ln 3. And then you plug in the -1, okay? So that is 1, I have no space. So minus, so that is now 1 plus 1 plus 2 ln1, ln1, all right? But again, then now let us simplify. So this is now 2 ln 3 minus 1 plus 1 is 2, ln1 is 0, so this is now 0, so minus 2. So 2 ln 3 minus 2. Now let's try to plug in from 0 to 3, okay? Oh, it appears that we can just actually substitute directly, okay? Hold on. So what we're gonna do now is plug in the 3. So this is now, I will just use other color. Okay, okay. So this is now, I plug in the 3, okay? So you have there now 3 squared, so that is 9 minus 3 plus 2 ln 6 plus 3 is 9, okay? Then whatever the answer to that, you minus, you plug in the 0. Again, 0, 0 minus 2 ln 3, so 2 ln 3. All right, so this is now 9 minus 3 is 6 plus 2 ln 9 minus 2 ln 3. Okay, then this is now minus here. So let me just write it in one line. 2 ln 3 minus 2. All right, then you have there, this is plus here. So plus from 0 to 3. So 0 to 3 now is 6 plus 2 ln 9 minus 2 ln 3. That's it. So you have there now 2 ln 3 minus 2 ln 3 is 0. Negative 2 plus 6 is 4. So 4 plus 2 ln 9. Okay? It looks like a bit complicated because I integrated that graph, okay? But let's just see if the answer will be the same if we just do it directly. I think it will be the same, okay? Because the graph a while ago is not that accurate, but actually the one that I have done is the correct process. You actually need to analyze the question one by one graphically in your head, okay? So now let's try to do this one directly. So this is going to be 9 minus 3 plus 2 ln 9, and then minus, you plug in the -1, so that is equal to 1 plus 1 plus 2 ln 1, ln 1. So therefore, this is 6 plus 2 ln 9 minus 1 plus 1 is 2. That is 0 minus 2. So therefore, this one will give you 4 plus 2 ln 9. Okay, so which turns out to be the same. Again, I did not complicate that matter. It's just like I want to show you the geometrical interpretation of the problem, that there is that oblique asymptote and the horizontal asymptote. Okay, but based on my experience, I haven't encountered some questions like for example like this, and then there's a graph like that, as what I've told you, and then you're being asked for the area up to here. Okay, what you're gonna do is that take that region and then take that region, R1, R2, then you add them up. Okay, you cannot just simply do from here up to here all the way, because they will cancel each other. Okay, so don't do that one. All right, but normally it can appear into some sort of difficult problem, but seldom in paper 3. So now let's go to, I think I'm done with this one. I'll just try to, okay, I'm gonna give you, for example, one more. All right, I would like you to look at number 4 and then number 5. Okay, so you have there, I think this is taken from the past papers. So take a look at letter A, given that this is equal to this. Okay, find the value of the constant A, hence show that this is equal to this. What you're gonna do is just simply use your answer in letter A to answer the letter B. Okay, so how are we going to do that? Okay, so how are we going to do that is that we can just equate, to find the A, we can just equate the 2. Okay, so again, you have there 2 times, let's make them equal with each other, 2 times 2x minus 1 plus A over 2x minus 1, and that is equal to 4x over 2x minus 1. Again, there are many ways to do this one. You can use any other method that you wish. There is no problem with that one. All over 2x minus 1. So as you can see in here, that this and these are equal to each other. So it appears now that negative 2 plus A is equal to 0 because there is nothing there, only 4x there. So therefore, your A is equal to 2. Okay, so the A now is equal to 2. Again, you can just pause the video or you can just stop it and go back to each step by step. So I'm going to plug in this to be equal to 2. And now we will try to answer this question. So you have there now the integral of 2 plus 2 over 2x minus 1 with respect to x is equal to 2x plus 2 times 1/2 ln 2x minus 1. And then you have there from 1 to 5. So let's do from 1 to 5. You plug it in. So 5 times 2x is 10 plus this is cancelled with each other. ln 10 minus 1 is ln 9 minus you plug in the 1, that's 2 plus ln 0. Okay, because 2 times x, okay, 2 times x is 2 times 1 is 2 minus 1 is 1. ln 1 is equal to 0. Okay, please don't forget. Oh, sorry, this is wrong. Okay, let me just write ln 1 there. So therefore, this is now 10 plus ln 9 minus 2 minus 0. So therefore, that is 8 plus ln 9, which is actually have been shown. Okay. So what is the difference between further math and the pure mastery? In further math, there's nothing like this. So just directly to this one. Okay. In further math, again, there is no clue like this. Just directly this one. All right. So in pure mastery, everything is step by step. Okay. So again, you just need to that's all for this one. Just follow each steps and then you would be able to make it. Okay. I'll gonna give you some seat work. Just follow the worksheets that I gave and see you on the next video. Thank you.